This video is about finding the area of a regular polygon and finding the area of a shaded region. So before we get into that, we need to use some of our vocab words that we learned before and some new vocab words that will help us with finding the area. So with polygons, remember there are many different types of polygons, but some of them have specific names, and that tells us how many sides they have. So remember, a triangle has 3 sides, a quadrilateral has 4, a pentagon has 5, a hexagon has 6, a heptagon has 7, an octagon has 8, a nonagon has 9, a decagon has 10, a dodecagon has 12, and an n-gon has n sides. So if I say an 11-gon, that means it has 11 sides. If I say a 30-gon, it would have 30 sides. So let's look at some more vocab. So a regular polygon. A regular polygon are the only types of polygons that we can find an area for. So to have a regular polygon, it needs to be equilateral, which means all of the sides are congruent, and it needs to be equiangular, which means all of the angles are congruent. So a couple of vocab words which will help us when we're trying to find our area. The first is the central angle. So the central angle is an angle whose vertex is at the center of the circle or the polygon. So here is our central angle, and we connected these two vertices of the polygon together. This whole angle then is our central angle. To get the measure of the central angle, we're going to do 360 divided by the number of sides. Then the line that's drawn from the vertex at the center to one of the vertex of the polygon, that is going to be our radius. Which we can represent with r. And then we have our altitude, or our apothem. So our apothem is a segment that's drawn from the center to the midpoint of the side. So we go from the center down to the midpoint of the side. It's also going to be perpendicular. We can use an A for that. So to find the area then of a regular polygon, we are going to use area equals 1/2 apothem times perimeter. So the little a stands for the apothem length, and P stands for the perimeter of the polygon. So before we can start finding our area, we need to talk about finding the angle to help us find the information that we need. So here we have 3 different shapes. We have a pentagon, a hexagon, and an octagon. So what we're going to do to find the angle, we only want half of that central angle. So to find this angle, we're going to do 360 divided by the number of sides and divide by 2 because it's only half the triangle. So 360 divided by 5 is 72. Divided by 2 gets us 36 degrees. And then we would have our radius and our apothem. In a hexagon, we have the same idea with our apothem and our radius. To get our angle, we do 360 divided by 6 sides divided by 2. So that gets us 60 divided by 2 is 30 degrees. And our last one is an octagon. So in an octagon, we have 8 sides. So we're going to do 360 divided by 8 divided by 2, which will get us 22.5 degrees. So notice, as you have more sides in your polygon, the central angle is going to get smaller and smaller. So now that we've gone through this, we can start finding the area of our different shapes. Remember when we want to find the area of a regular hexagon with a perimeter of 60. So that's really good because that already gives us our P of our equation. We also need to use that to find our side lengths. So if there are 6 sides, 60 divided by 6 means that each side is going to be 10. When we draw in our triangle with our apothem, we know that that side splits then into 5 and 5. So one side of the triangle is 5 right now. To get the angle, 360 divided by the number of sides divided by 2 gets us 30 degrees. So this has now created a 30, 60, 90 triangle. So we can use special right triangles to find our missing sides. We have S, S root 3, and 2S. Well, we know the S side is 5, so that means our apothem is going to be 5 root 3. So now we have everything we need to find the area. So our area is equal to 1/2 times the apothem 5 root 3 times the perimeter of 60. So that gets us 150 root 3 centimeters squared. In number 2, we have a regular octagon. So in this case, the octagon gave us our apothem, so we need to find the side length so we can get our perimeter. So we know that the apothem is 12. To get our angle, we have 360 divided by 8 divided by 2, which will get us 22.5 degrees. So now this time, if I'm trying to find my side, I need to find this part first because I know it's bisected to get me that whole side. Now, in this case, when we are doing the area, we want to find that side length, but the angle is not a 30/60/90 or a 45/45/90, so instead we're going to have to do trig. Now, when we do trig, we don't want to get our decimal answer until the very end. So for now, we're just going to set up our trig. We have opposite and adjacent. So the tangent of 22.5 is equal to our opposite side x over our adjacent side 12. So when we multiply, we get 12 times the tangent of 22.5 equals x. So if we double that, this whole side then is going to be 24 tangent of 22.5 because we doubled this side. So now, to get our perimeter, we have 8 sides that all have that length. So we would have 8 times 24 tangent of 22.5. And that would get us 192 tangent 22.5. So now that we have our perimeter and our apothem, we can do our area. So our area is going to equal 1/2 times 12 times 192 tangent of 22.5. Now at this very end step when we're looking for our answer, now we can type the whole equation in. Remember when you're going to put this in your calculator to check that if we're using trig that degrees has the black box around it, which it does in this case. So we can type our equation, 0.5 times 12 times 192 tangent of 22.5. We're going to round to the nearest thousandth, so 3 decimal places. So our area is going to equal 477.174 meters squared. So in 3 and 4, we don't have a picture. We don't have to worry about drawing out that whole shape. All we need really is that triangle that we're drawing into the other thing. So I'm going to draw the whole triangle though, because I want the whole side length. So here in our pentagon, we have our radius, we have our apothem, and this is going to represent our side. So in this case, we know that the radius is equal to 9. If we are trying to find the number for our angle, we would do 360 divided by 5 sides because it's a pentagon divided by 2 is 36 degrees. So we need to do trig twice in order to get our apothem and to get our perimeter. So if we are looking at our shape, we have opposite, adjacent, hypotenuse. So to get our side, we would use sine because we have O and H. So the sine of 36 is equal to x over 9. So we get 9 sine of 36 equals x. So each side of our apothem is 9 sine of 36, which means the whole side is 18 sine of 36, which that will help us find our perimeter. So our perimeter, we have 5 sides times 18 sine of 36. So that gets us 90 sine of 36. Now, we're not ready to solve yet because we also need our apothem. So I'm going to call the apothem y. That is our adjacent and hypotenuse, so that is cosine. So the cosine of 36 equals y over 9. So we get 9 times the cosine of 36 equals y. So that is our apothem. So now, using our apothem and our perimeter, we can find our area. So our area is equal to 1/2 times 9 cosine of 36 times 90 sine of 36. So in our calculator, we can type that all in. 0.5 times 9 cosine of 36, close your parenthesis, times 90 sine of 36, close your parenthesis, and we get 192.589. So our area is equal to 192.589 millimeters squared. In number 4, we have a nonagon with a side length of 22. So again, I'm only going to draw in the one triangle. Here is my apothem that bisects the side. So if the side is 22, that is bisected into 11 and 11. To find our angle, we have 360 divided by 9 sides, divided by 2 is 20 degrees. We need to know what our apothem is. So we have the opposite and the adjacent side, so we're going to use tangent. So we have the tangent of 20 equals 11 over x for my apothem. So we're going to switch the x and the tangent. So that is x equals 11 over the tangent of 20. To get our perimeter, we know that each side is 22 and it's a nonagon, so it has 9 sides. So our perimeter is going to be 198. So now we have our apothem A and our perimeter P. So our area is going to equal 1/2 times 11 tangent of 20 divided by the tangent of 20 times 198. So in our calculator, we have 0.5 parenthesis 11 divided by the tangent of 20. Make sure you put 2 parentheses to close the tangent and the overall parenthesis, times 198. And we get 2,992.003. So our area is equal to 2,992.003 meters squared. Number 5 is a word problem. So number 5, the measure of an apothem of an octagon is 14 and the area is 1,697.5 meters squared. Find the perimeter of the octagon. So we know that our area is equal to 1/2 apothem times perimeter. So we have 1,697.5 is equal to 1/2 times 14 times the perimeter. Half of 14 is 7. So we can divide both sides by 7 and we get our perimeter is 242.5. So it'd be 242.5 meters. Number 6 is another word problem. So in this word problem, the area of the pentagon is 582 millimeters squared, and the measure of one side of the pentagon is 13 millimeters. Find the apothem. So we said that the area is equal to 1/2 apothem times perimeter. We don't have either of those right now, but we have a side. So our perimeter is going to equal 5 because it's a pentagon, so 5 sides times 13 is 65. So now we have 582 equals 1/2 apothem times 65. Half of 65 is 32.5. So we have 32.5 times the apothem. When we divide, our apothem is going to round to 17.098. So we have 17.908 millimeters. Number 7, the span, which is S, of a regular hexagon is 40 millimeters. So span is a new word. Span is going to equal 2 times the apothem when we have an even number of sides. So a hexagon has 6 sides. So in this case, our span is going to split in half to 20 and 20. So our apothem is 20. So if we have a span that is 40 millimeters, we can just draw our triangle here, knowing that we have an apothem of 20 because it's half of our span. So in a hexagon, when we look for our angle, we have 360 divided by 6 divided by 2 is 30 degrees. So we're going to use our special right triangle. So we have S root 3, and 2S. So we need to know what S is going to equal. So we need to do 20 divided by root 3 and rationalize. So we have 20 root 3 over 3, and we can't simplify that anymore. So if this is 20 root 3 over 3, the whole side is going to be 40 root 3 over 3, which means our perimeter, if we have 6 sides, times 40 root 3 over 3 is going to equal 80 root 3. So now we can find our area. So our area is equal to 1/2 the apothem, which is 20, times the perimeter, which is 80 root 3. So we get an area of 800 root 3 millimeters squared. So in B, we want to find the area of the regular hexagon with an area of 24 root 3 millimeters squared. So we know that in our triangle, we have an apothem that we don't know, and we have sides that we don't know. So if we call this part X with our 30-degree angle, that would make our apothem X root 3, and that would make the whole side 2X, which means if our apothem is X root 3 and our perimeter is 6 sides times 2X, which is 12X, we can find X now. So the area is going to be 1/2 times the apothem times the perimeter is equal to 24 root 3. So when we multiply here, we get 6x squared root 3 equals 24 root 3. So we can divide both sides by 6 root 3. So we get x squared equals 4. Take the square root. We know x is 2. Now, your apothem was equal to x root 3, which means it is now 2 root 3. So to get our span, we have to double that. So our span would be 4 root 3 millimeters. Number 8, our last problem of finding the shaded region. So here we have a hexagon, and because it says assume all figures are the same, or all regular, that means that we also have an equilateral triangle. So first, we need to find the sides of our equilateral triangle. So in order to do that, I'm going to find what this whole angle is. So each interior angle in a hexagon, remember, is 180 times the number of sides minus 2 divided by the number of sides. That's 120 degrees. If I split it in half, though, that gets me 60 degrees and 60 degrees. So I now have a special right triangle, 2s, s, s root 3. So if 14 is on the 2s side, we divide and get 7, which means this is 7 root 3 on both sides, making the whole side of the triangle then 14 root 3. So we're going to use that part later on. We're also needing to find the information in our hexagon. So in our hexagon, when we draw our triangle in, we know that the side is 14. That's split into 7 and 7. We know in a hexagon, our top angle is always 30 degrees, which means our apothem is going to be the s root 3 side, so it's going to be 7 root 3. So to get our shaded region, we want to do the area of the hexagon minus the area of the equilateral triangle. So to find the area of the hexagon, it is 1/2 times the apothem times the perimeter. So if each side of our hexagon is 14, we have 6 times 14, which gets us 84 for our perimeter, minus the equilateral triangle. So the equilateral triangle is √3/4 times 14 √3 squared. So the area of the hexagon, when we multiply, we're going to do 0.5 times 7 times 84. And we get 294, but we can't forget the √3, so we have 294 √3 minus, in our calculator, we're still not going to put the √3, so we're going to have parenthesis 14 √3, close parenthesis, squared, divided by 4, which gets us 147 √3. And when we subtract those together, we end up with 147 √3 centimeters squared.